Good afternoon. My name is Jeff Clayton, and I'm the CEO of GenesisDNA, the next generation of gene synthesis. Virtually every experiment in biology begins with the right DNA sequence. But today, outdated and inadequate tools for writing those sequences are choking progress. Take this sample of 580 sequences ordered from services for writing DNA. Over half of them were delayed for weeks to months, wasting time and money. But let me emphasize the real cost of this problem, because every one of those sequences was actually a new idea, and every failed synthesis, an idea that we miss out on. These could be microbe-derived plastics and fuels, cancer therapeutics, new paradigms in data storage. In these areas, writing DNA is already a $1 billion market opportunity, and it's the fundamental tool that will help make them a reality. So we have to do better, because at its core, writing DNA has changed very little from a hand-built process first developed in the 70s. That's synthesis 1.0, stitching together a bunch of shorter pieces of DNA to build a full-length product. But this is like soldering a bunch of extremely small electronics by hand with different tools every single time, because different building blocks are used for every sequence, and if you use the wrong building blocks, the synthesis will fail. And today's synthesis 2.0 isn't much better. It really just runs the same inefficient process in parallel and fails to solve these fundamental problems. So clearly, it's time to move away from hand building and towards something much more like this. Pick-and-place machines revolutionized electronics with rapid and cost-effective board assembly using standardized parts. That's what inspired us, and that's what we built. GenesisDNA is synthesis 3.0, the world's first pick-and-place machine for DNA synthesis that finally standardizes an unpredictable process. Here's how. We start with a grid of standard DNA parts and a magnetic bead that contains starter strands of DNA. When the bead is at a particular spot on the grid, the DNA on both surfaces interacts. Then enzymes in solution extend the DNA on the bead, which then departs from spot A towards spot B for the next extension cycle. Now here's the magic. By containing standard parts, the same grid can be used for every sequence that we build. And unlike everyone else, we don't do any stitching. Our grid is not consumed in the process of building and can be reused again for the next order. See, that's the pick-and-place advantage. Predictability and reusability means that synthesis can be fully automated at every step along the way for a significant reduction in cost. At scale, our system will be moving thousands of beads simultaneously and independently for costs at a mere fraction of a cent per base pair. Here's version 1 of our platform, where you can see a computer-side control algorithm interfacing with magnets to move 3-micron beads to programmable target positions. And now the best part. It works. It builds DNA. We built short pieces of DNA as proof that pick-and-place can work for DNA synthesis, which brings us one step closer to our vision of the ideal synthesis service. A customer uses our website to order a custom DNA sequence, which is sent to our synthesizer, QC'd, packaged, and shipped back to the customer with this promise. For every sequence ordered, we promise one price per base pair, one delivery date, no ranges, and no changes, which will make us the only service on the market with industry-leading prices and exact turnaround times, with the ultimate goal of removing synthesis as a bottleneck by offering custom DNA at 1 cent per base pair, delivered under a week for both simple and complex sequences. This is something that companies today want. We already have 8 letters of intent to participate in beta trials when our platform is up and running, and we plan to reach them as quickly as possible. So today, we're working hard to build longer DNA sequences and close a seed round for the development of a full-scale gene synthesis platform by Q2 2017 that's ready for these trials. The revenue from these trials will help us build our multi-bead system and kick off growth into the US market for standard genes. Over the following 5 years, our increasingly strong product portfolio of libraries and combinatorial gene clusters will make us a world leader in DNA synthesis. By 2020, we want inefficient and unpredictable synthesis to be a thing of the past. We've felt the pains of inadequate synthesis tools firsthand and for too long, so we're determined to do something about it. We are a team of material scientists and bioengineers from MIT and Stanford, with advisors who are world leaders in synthetic biology, who have founded companies that went through billion-dollar IPOs, and who have built and scaled gene synthesis platforms in the past. That makes us the right team for the job. Today, we're raising $1.5 million to build the tool that will build the future of biology. Come meet us at our booth to see our pick-and-place machine in person. Thank you.